Hi, in this lesson we want to talk about arithmetic patterns. So the first aspect we want to discuss is the arithmetic sequence, which is characterized by the following equation. Tn is equals to a plus n minus 1d, which I'm sure it's not the first time you see this equation. You're also familiar with y is equals to mx plus c, and there are similarities between these two formulas. So both express a linear type of growth, meaning if we were to take an example of an arithmetic pattern, a very basic one would be 2, 4, 6, 8, 10. Now if we were to calculate the difference being the difference between term number 2 and term number 1, or term number 3 and term number 2, or term number 4 and term number 3, and so forth, we would find that there is a constant difference between our terms, and that is what characterizes a arithmetic sequence. It is a group of numbers that are related by their common difference between their consecutive terms. So an arithmetic pattern is a sequence of numbers in which the difference between consecutive terms remains constant. Now the types of questions you can expect here are questions where they ask you to find what the general term of that sequence is. Now that's what this formula does. This formula finds the Tn, or the value of a certain term number. So this is term number 1, term number 2, term number 3, but we can go on and on up until term number 101, for example. If we want to know what term number 101 is, we simply use this formula. But how do we apply this formula? We need to first know what a is. Now a is the first value of our pattern. D is the difference in our pattern, and then n is just the input variable. So n would represent the 101 that we are trying to figure out. We simply plug in our values and then we evaluate. What I'd like to talk about a little bit more is the arithmetic series. Now, given the same pattern, 2, 4, 6, 8, let's leave it at that. Now, with an arithmetic series, the only difference is the sign we use to separate our terms. In an arithmetic series, the goal is to find the sum of a certain number of numbers. So we're trying to find the sum of n numbers. With arithmetic sequence, we were trying to find the certain value of a term number, but with arithmetic series we're concerned with the sum, and here we're concerned with the term value. So where we have T5 or T3 representing term number 3, the term number or the term value at term number 3, we can have S3, which represents the value of the first 3 terms summed up together. So in this case, S3 would be 12, but T3 would be 6. Now, how do we find the sum of a given pattern? Let's say we want to find the sum of the first 1,000 numbers of this pattern. What we would need to do is we need to use the following formula: n over 2, 2a plus n minus 1d. Or, given that you know the value of the last term, you can use n over 2a plus l, where l is the value of the last term. So let's say you wanted to sum up from term number 1 to term number 4. You would basically substitute how many numbers you're trying to add up, which is n, that would be represented by 4. And you have a, which would be the first term as well. Then l would be the value of the last term, which is 8. But the more common example would be the first one, which we use when we don't know the value of the last term in our pattern. So using these two formulas, we're able to evaluate the sum of a different amount of numbers. Now, in the rare case that, well, not actually rare, but in the case where they only give you the sum of formula, so let's say we get the sum of formula and it's simplified to something like 3n plus 2. So this is the only information you're given. And I'm not saying this one pertains to this example. Maybe let me write it on a separate space. So let's say we are given Sn is equal to 3n plus 2. Find term number 2. Well, how would we do that? We are only given the formula that finds the sum of n numbers, not the one that gives us the value at that term number. So given term number 1 and term number 2, how do we find term number 2? Because all this formula can give us, well, actually, if we put in 1 into this formula, we can get the first term because it will just be adding this and nothing else. But the moment we put 2, we are now including t1 plus t2. Well, how can we get t2 out of this? Well, we can subtract t1 from this. So if we take this, which represents the sum of the first two numbers, and we subtract that, which represents the sum of the first number, then we can get out of it, because t1 will be cancelled by t1, the result of this would be term number 2. So from this we can actually derive another formula which states that term number n is equal to the sum of those n numbers minus the sum of n minus 1 numbers. So another example, same example, but now we're looking for t7. What we want to do is we want to find the sum of the first 7 numbers. Then we remove the sum of the first 6 numbers. This isolates it such that we are left with just term number 7. Hopefully that makes sense, and that is all you will need to know about arithmetic patterns.